I am Dr. W.B. Gunale from Kamlani Mahavidyalaya, Nagpur. Today we are going to discuss the chapter number 7, and the name of this chapter is the element of group number 16, 17 and 18 elements. And group number 16 is known as the oxygen family. Group number 17 is known as halogen family, and group number 18 is the noble gases. So group number 16, 17 and 18, that is oxygen, halogens and the noble gases. Their electronic configuration, their physical properties, chemical properties and some other aspect we are going to discuss in this chapter. And today we are going to discuss the what are the general characteristics and also what are how the elements of these groups occur in the nature. And after that, electronic configuration and important physical properties, that is atomic and ionic radii. Electron after that the ionization potential, and after that the some other properties we are discussing in today's presentation. So today's topic is the element of group 16, 17 and 18. This is the chapter number 7, and this is the first part that we are going to discuss the different aspect of the group number 16, oxygen family, halogens and the noble gases. So the topic that we have covered in today's presentation are the introduction, occurrence, electronic configuration of the element of the group number 16, 17, 18, atomic and physical properties of the element, and group number 16, 17, 18, atomic and ionic radii, ionization enthalpy, electronegativity, electron gain enthalpy. So all these parts we are going to discuss in today's presentation. So first part is the as we know, group number 16, 17 are shown here, and here is the group number 16. The group number 16 first member is the oxygen, therefore this is known as oxygen family, and the elements are oxygen, sulfur, selenium, tellurium, polonium. And group number 17 is the first member is fluorine, and chlorine, bromine, iodine, all these are known as the halogen. These are the halogen elements, and therefore the complete group is known as halogen family. And the halogen family contains fluorine, chlorine, bromine, iodine, astatine, and this is another element. And group number 18 are the noble gases or zero group element, and these noble gases are helium, neon, argon, krypton, xenon, radon and ozium. So what is now, these are the elements of the three groups number 16, 17 and 18, and all these groups are belong to the p block element. So the what is p block element? We can say that when the element in which last electron enter into the p orbital, therefore these elements are known as p block element. So as we know, this is the periodic table, modern periodic table, and the left side having S block element, right side having p block element, and in the middle d block element, and at the bottom f block element. So elements are being classified according to their atomic number, and here this is the modern periodic table, and now we are discussing the p block element, and in which p block element group number 13, 14, 15, 16, 17, 18 are there, but only in this syllabus 16, 17, 18 are there. So detail about the group number 16, 17 and 18 we are discussing. So here, in this case of oxygen family, halogen and noble gases, some properties are there, and that general properties are so first of all we are going to see the what is occurrence. As we know, different elements are there in all the three groups, and in group number 16, which is known as oxygen family, and this family contains 5 elements: oxygen, sulfur, selenium, tellurium and polonium. These elements are known as chalcogen, or also known as ore forming element, because many metals are occur in oxide and sulfide. These elements belong to p block, and the first 4 members are non-metals. Polonium has metallic character and is a radioactive element with a very short life period. And also we can say that oxygen, the most abundant element, is the important constituent of atmosphere and the ocean, and it constitutes 46.6% of earth crust. It forms 21% of air as the free element and 89% of the ocean by weight. Sulfur is less abundant and occur in free and combined state. It forms about 0.052% of the earth crust as compared to oxygen, and sulfur, the most other member of this group, are rare. And group number after this, what is the halogen family? And in case of halogen family, we can say that the non-metallic element fluorine, chlorine, bromine, iodine and astatine are the elements which are present and in this group and shown in the periodic table. Their salt are present in seawater, and hence they are known as halogens. In Greek, halos means sea salt producer. The group collectively is also known as halogen family. All halogen precede the noble gases in the periodic table because their atoms contain one electron less than electronic configuration of the inert gas. They have very strong tendency to acquire stable inert gas configuration by accepting one electron. For this reason, halogen exhibit non-metallic behavior. Astatine is the last member of halogen family, is a radioactive element with a very short life. All other halogens are abundant in nature in the combined state, and very high electronegativity of halogen make them very reactive, and hence they are not found in free state. In combined state, fluorine occur as a crystallite or fluorspatite. Chlorine is the element found as a sodium chloride present as a rock salt or in seawater. Bromine occur in seawater as a bromide of alkali and alkaline earth metals. Iodine is found as a sodium iodate in chili salt peter and as a alkali metal iodides, and alkaline earth metal iodide in seawater. So these are the occurrence of this halogen family. And last group is there, and which is known as the noble gases. As we know, the element helium, neon, argon, krypton, xenon, radon are grouped together in group number 18 of the periodic table. All these elements are gaseous under ordinary condition of temperature and pressure. The last number of group, that is radon, is a last element of the group, that is radon, is obtained from radioactive disintegration of radium. All other are present in air in traces. They are also known as rare gases because they are found very small quantities in the nature. They are highly non-reactive and do not take part in the chemical combination to form compounds like other elements and are therefore known as inert gases. Because of their inert nature, noble gases always occur in free state. All the noble gases except radon are present in air in small amount. The relative abundance of noble gases in air is also given, and helium is also present in natural gas up to the extent of 10%. It is also present in small quantity in the minerals of radioactive element. Water from certain springs also give off gases which are rich in helium and argon. Helium atom contains 2 electrons in its outermost shell, and therefore these are the details about the 3 groups: group number 16, group number 17 and group number 18, and their occurrence is given here about the group number oxygen family and also halogens and the noble gases. So these are the elements, and 3 groups are there: group number 16, 17 and 18. Now the important part of this group number 16, 17 and 18, and in this case together the electronic configuration of all the 3 groups are given in this table of 7.1. So this is the condensed electronic configuration of the element of group 16, 17, 18. So these are the elements as we know: oxygen, sulfur, selenium, tellurium, polonium. And this is the electronic configuration. Oxygen have atom number 8, 16, 14 here, sulfur have 16 and 34, 52, 84, and here 8 electron configuration. So helium is complete, 2 electron, and remaining 6 electrons are here, 2s2, 2p4. And as we know, in case of group number 16, the outer electronic configuration of valence shell or general electron configuration is NH2, NP4. In case of group number 17, NH2, NP5. In case of group number 18, NH2, NP6. So in the valence shell, see now, last electron goes to the p orbital in all the elements, and here 4 electrons present in all the p orbital. Here 5 electrons present in outer shell, and here 6 electrons present in the p orbital. So depending upon, because here this is the one by one the incoming electron, as atom number increases, the incoming electron goes to the p orbital. See here, 2p4, 2p4, 3p4, 4p4, 5p4, 6p4, like that. And in this case, incoming electron also goes to the p orbital. So 2p5, 3p5, 4p5, 5p5, 6p5. In this case, 2p6, 3p6, 4p6, 5p6, 6p6. So in this way we can write the, and these are the configuration: helium, neon, argon, krypton, xenon. And in this case, here in bracket, instead of writing long configuration, so write the in square bracket helium, neon, argon, krypton. इस टाइप से लिखने के बाद फिर वैलेंस शेल का कॉन्फ़िगरेशन लिखना है, NH2, NP4, like that. So this is the configuration, and because this is the group, here number of shells here one by one, as we go down the group, number of shells increases. So therefore principal quantum number also increases. So here this is the table shows the condensed electronic configuration of the group number 16 oxygen family, group number 17 halogen family, group number 18 noble gases. So here also in case of electronic configuration and general electronic configuration, as we know that outer electron configuration, in first case NH2 NP4, in second family NH2 NP5, in third NH2 NP6. So these are the electronic configuration and general outer electronic configuration for all the three groups 16, 17 and 18. Now some physical, atomic and physical properties of group number 16 and 17 and 18 are here, and in this case of physical properties, 4 important properties are there, and these 4 important properties are: first is the atomic and ionic radii, second is the ionization potential, and third is the electronegativity and electron gain enthalpy. So there are these 4 properties we are going to discuss, and first is a table is also given here for all the 3, and in this table see now here the atomic and physical properties of group number 16, 17 also given, 18. So in case of this 16 group element, these are the elements shown: oxygen, sulfur, selenium, tellurium, polonium. Atom number 8, 16, 34, 52, 84. Atomic mass is also given here, and atomic radius is given. So now see it is increases. Ionic radius also show the increase, and ionization enthalpy also show the decrease, and electronegativity also show here the decrease. As we go down the group, one by one we are discussing all the properties. And so melting point, boiling point also given, density is given. So first property is atomic and ionic radii. As we know, what is atomic radii? It is nothing but the atomic radii can be defined as the distance between the center of nucleus to the outermost shell of electron. So this is known as atomic radius. In case of ionic radius, in case of ion, it is known as ionic radius. And as we know, as we go from left to right in the period, atomic size decreases because number of shells are same, and incoming electron goes to the same shell, and therefore force of attraction increases, and because of that as the force of electron increases, and size of atom decreases as we go from left to right, and therefore atomic and ionic radii both decreases. But as we go down the group, number of shell increases, and therefore atomic size and also the atomic and ionic radii increases. So in case of this group number 16, 17, 18, in this case also, in this case group, in case of this also, the this table also shows clearly the in case of group 16, 17 and 18 the atomic and ionic radii increases down the group because of the increase in the number of quantum shells. As we know that in case of group these are the three groups, and as we go down the group from top to bottom in the group, the atomic size increases. The size increases because number of principal quantum number shells or number of shells increases. So first, second, third, only 7 pairs are there, and therefore 7 shells are there. As we go down the group, number of shell increases, and because of that the size increases, and because of increase of size, force of attraction between the positive nucleus and the valence electron decreases, and with decrease of that, what is the atomic and ionic radii increases from top to bottom in the group. So in case of group number 16 and 17 and 18, the we can say that atomic and ionic radii both increases with the increase of we can say that with the increase in the number of quantum shells. And in case of the as we know also, in the atomic and ionic radii decreases with the increasing atomic number in case of the period, and in period it is because of the effective nuclear charge, and have the smallest atomic radii in their respective period, and with the increase of atomic number, so we can explain the decrease of atomic and ionic radii in the period, and increase in the as we go from top to bottom in the group. So, and values also given in the table, and this value shows clearly here. See the atomic radii C66104, it is show clearly the atomic radius value increases of this group number 16. So here it is also increases. So atomic and ionic radii both increases in case of the group number 16. So what is now in case of group number 17? This is the table, and here in case of group number 17, atomic radius, ionic radius also show the increase. In case of group number 18, the value of atomic radius and ionic radius, atomic radius and also ionic radius, in case of this also show the increase of the value. So atomic radius, ionic radius in all the three groups increases as we go down the group. So this is the first property, that atomic and ionic radii. Second is the ionization enthalpy, or also known as ionization potential. As we know that in case of these group element, these elements have larger value of ionization energy, which decreases gradually from oxygen to polonium. In case of group number 16, oxygen has very high ionization energy, and the decrease in ionization energy from oxygen to polonium is due to the increase in size of the atom and increase in scaling effect of the electron belonging to the lower shell. So we can say that here it is a ionization potential or ionization enthalpy increases from left to right in the period, and also it is decreases from top to bottom as we go from top to bottom in the group. So in case of group number 16, 17, 18 element, they have high ionization enthalpy. The ionization enthalpy decreases down the group due to the increase in the atomic size. And in case of period, ionization enthalpy increases with the increase of atomic number, and this is due to the addition of electron take place in the same shell. In case of the element of group number 16, they have lower ionization enthalpy value as compared to those of group number 15 in the corresponding period, owing to the due to the extra stable half field electronic configuration of p orbital in element of group number 15. So here so values are also given in case of the element of this group. So ionization enthalpy, so see here in case of group number 17 and also in case of group number 16, ionization enthalpy, so see now value decreases as we go down the group. In group number 16, ionization enthalpy value decreases. In case of group number 17, ionization enthalpy value also show the decrease. In case of group number 18, ionization enthalpy value also show the decrease. So value decreases, and as we know, ionization enthalpy can be ionization enthalpy is second property, also known as ionization energy. This is the amount of energy required to remove electron from the outermost shell. So amount of energy required to remove, as we know that force of attraction increases from left to right in the period, and force of attraction decreases from top to bottom in the group. And as we know, as the force of attraction increases from left to right in the period, so it is difficult to remove electron from the outermost shell, and therefore ionization potential or ionization enthalpy increases. As we go down the group, the force of attraction decreases, and therefore it is easier and easier to remove electron from the outermost shell, and therefore ionization enthalpy decreases as we go down the group in all the three groups. So this is second number, and third number property is electronegativity. And as we know that in case of electronegativity, what is the electronegativity? So we can say that it is the tendency of an element to remove to attract the shared electron pair toward itself in the covalent bond. This tendency or ability is known as the electronegativity. Again, I am repeating, what is electronegativity? It is the tendency of or the ability of an element to attract the shared electron pair toward itself in covalent bond. For example, HCl. So shared electron pair is attracted by the Cl. So it is more electronegative as compared to the H. So in this way, and the electronegativity of group number 16, 17 and 18 also given in the table. And electronegativity in case of oxygen family, oxygen is strongly electronegative in character. The value of electronegativity decreases with the increase in atomic number down the group, and this is due to the increase in size of the atom and decrease in effective nuclear charge as we go down the group. And as we know, in all the elements, in case of halogen, I have only one electron less. And here in case of group number 16, see, in case of 16, electronegativity value show here, show the decreases. So this 3.5, 2.4. So in case of halogen, group number 16, oxygen family, see the electronegativity value decreases. In case of the group number 17 also, the electronegativity value, see now here, fluorine is the strongest electronegative element in all the elements in the periodic table, and the value is electronegativity value is 4. So 4, 3.2, 3, 2.0, 2.2. So again, in case of halogen, only one electron is short to complete this stable configuration, and fluorine is the element which have highest value of electronegative. So it is strongest electronegative element, most electronegative element in all the elements in the periodic table. And value in case of group number 17, electronegativity value also decreases. And in case of group number 18, so here the electronegativity, so they are not electronegative, so value is not given because it cannot electron, they lose or they gain electron, because there is no group number 18 cannot show the addition of electrons. So they here they cannot show the electronegativity. And in this case of group number halogens, in case of halogen family, the electronegativity is shown and it is high. And in case of we can say that in case of noble gases or the group number 18, they do not show any, because they have stable electronic configuration. So here first two group, first two that is group number 16 and 17 show this electronegativity, and also table shows the value of electronegativity. And so we can say that group number 16, 17 and the electronegativity decreases down the group. Oxygen has the highest electronegativity next to fluorine, because fluorine is the strongest in all the elements. Halogens have very high electronegativity, and fluorine is the most electronegative element in the periodic table. So this is the third property, and values also given in the table. And last property, electron gain enthalpy. And in case of electron gain enthalpy, here group number 16, 17 and gain enthalpy become less negative down the group. In case of group number 16, oxygen has less negative electron gain enthalpy than sulfur due to small atomic size. Group number 17, fluorine has the less negative electron gain enthalpy as compared to the chlorine. This is due to the small size of fluorine atom. And group 18 element, noble gases, have no tendency to accept electron because of their stable electronic configuration, that is NH2, NP6. All the orbitals are completely filled, and they have a large positive electron gain enthalpy. So in case, so this is the fourth one, electron gain enthalpy, and here the value is also shown in the table, and electron gain enthalpy. So here electron gain enthalpy shown. In case of all the three groups, electron gain enthalpy decreases, it is shown. And Based on all this, now here no problem is there that element of group number 16 generally show lower values of first transition enthalpy as compared to the element of corresponding group number 15, and why. So as we have discussed already, in case of group number 15, element have extra stable, that is half filled p orbital. They have, in case of group number 15, they have half filled p orbital, and half filled orbitals are more stable. And in case of group number 15, the electronic configuration is NH2 NP3. P3 means half filled. P have maximum 6 electron, and here in p orbital have 3 electrons, therefore here p orbital is half filled, therefore half filled orbitals are more stable, and in therefore more amount of energy required from the stable to remove electron from the stable configuration, and therefore here as compared to the group number 16 have NH2 NP4 of the group number 16 element configuration, and therefore group number 16 have lower value as compared to that of the group number 15. And another 7.2 is there, and in case of here the values of first ionization enthalpy of sulfur and chlorine are 1000 and 1256 kilojoule per mole respectively. Explain the observed trend. So we know that the observed trend is the element of sulfur and chlorine belong to the second period of the periodic table. In oxygen family, oxygen, sulfur, second element. In case of halogen family, fluorine and chlorine. So here sulfur and chlorine, as we go from left to right, belong to the second period of the periodic table, and in case of period, effective nuclear charge increases and atomic size decreases. As we know that as we go from left to right in the period, the size of atom decreases and force of attraction increases, and with the increase of force of attraction and decrease of size, and therefore with the increase in atomic number, and therefore energy required for the removal of electron from the valence shell increases in order of, and therefore sulfur have lower value as compared to Cl. So as we general trend is, as we go from left to right, the ionization energy or ionization potential, ionization energy increases. So why it is increases? And it is increases because force of attraction increases and size of atom decreases, and increase of force of attraction increases the value of ionization enthalpy or ionization potential, and here therefore sulfur is the first and then chlorine, and therefore as we go from left to right, here ionization enthalpy increases, and therefore sulfur have less as compared to chlorine. So this is the reason. Why is there is a large difference between the melting point and boiling point of oxygen and sulfur. So here reason is also given. In case of oxygen and the sulfur, oxygen exists as a diatomic molecule, as we know that, and whereas sulfur exists as a polyatomic molecule, that is S8. Oxygen exists O2 and sulfur exists as S8, and therefore van der Waals forces of attraction between oxygen molecules are weak due to much smaller size. And in case of large van der Waals attractive forces, in case of acid molecule of sulfur can be noticed, and because of large molecular size, the oxygen has lower melting and boiling point as compared to the sulfur. So oxygen has smaller size, sulfur have larger size, van der Waals forces are more, and therefore oxygen has lower melting and boiling point as compared to the sulfur. So this is the reason that depends on the molecular size and van der Waals forces of attraction. And so today we have discussed general properties, physical properties, electronic configuration of group number 16, 17 and 18. That is oxygen family, halogens and noble gases. So in this part we have discussed general properties, and in the next part we are going to discuss the physical properties of group number 16, 17, 18, and also different chemical properties and also some structures of the compound. So today we stop here, and we are discussing the remaining part in the next lecture.